Gonna wait for the number of viewers to go up. Doesn't look like that many people are watching, so I'll start in just a moment. Waiting just a moment for people to show up. Hello? Oh, not this guy. James? Get out of here, man. Don't you have better things to do? I only see 7 people watching, so I'm gonna wait like one more minute. And I know one of them is James Settles, so. Hello. This is a small class. Hello there. Hello there. All right, now people are coming in. Hello. Hello. So the number of viewers is increasing. So I think I'm going to start. So first of all, I just have some announcements. I wanted to, first of all, remind you to go to Canvas and click the daily attendance button and submit your attendance. You have a, you can submit a valid attendance 5 minutes before the class starts, all the way to 5 minutes after it ends. So any time within that window, your attendance will be counted. Immediately after this lesson, I will start the Zoom room, and you guys will meet me over there, and we will all work on the daily assignment for today. Okay? So that's how it'll work. If you have any questions that aren't answered in the Zoom room, then I invite you to come to the office hours at 2:30, or from 1:30 to 2:30. And for the office hours, I can give more individualized attention. I'll let you guys share your screen to me if you have a question about something. Let's see. Am I forgetting anything? I don't think so. All right. So let me switch to my document camera. Hello, everyone. Please let me know if, the one thing I wanted to say is if you have any questions, just type it into the live chat. I am monitoring the live chat. There's a question, should we take notes on paper or on docs or not at all? The answer is I don't care. So this is a college level class. You can do whatever works for you. I would probably recommend taking some kind of notes, but you don't have to. I'm not going to look at it or anything. Okay. All right. So I'm going, and please let me know if you can't read, if the resolution is too bad or anything like that, and I can move my document camera closer. So this is CHL. That's my code for this class because it's AP Physics C and IB Physics higher level. We got another great question. Will this video stay here forever or will you remove it? It will stay here. So basically, I will, the video will stay on my YouTube channel, and so you would just go to the corresponding date, okay? So you can view it afterwards if what I said doesn't make sense or anything like that. Okay, so this is the third, and these are the notes for period 5. Okay. So basically today is just a sort of mathematical preliminaries. So I'm going to talk about vectors. Okay. Vectors are the topic of today's lesson. And a vector is essentially an arrow. It has a length and it has a direction. So this is almost like a math lesson today, but I'm going to sort of focus on the physics aspects of it. And then tomorrow, or not tomorrow, but when I see you guys next, we will apply vectors to physics more directly. So a vector might be something like this. Okay. And so it's an arrow. All right. And if we look at this arrow, it goes over a certain amount and it goes up a certain amount. Okay. So the amount that the vector goes over is called the x component, or the horizontal component. Okay. That's how far it goes over. How far the arrow goes up is called the y component, or the vertical component. Okay. So this is a picture of a vector. If we want to represent the vector algebraically, let's say this vector is called v. Okay. And I'm just going to give some numbers to these components. So let's say that the x component is 2. And let's say that the y component is, 7. So this is obviously not, because it goes over more than it goes up, so this is obviously not what it actually would be. But here's how we would write the vector algebraically. We would say v, and when we write a vector, we put an arrow over the top, okay, to indicate that it's a vector. If you have a vector and you're reading that it's a vector in a textbook, in textbooks they don't do the arrow over the top, they do boldface. Okay, so if I were typing a problem for you, I would indicate a vector with boldface, but when I'm just writing it, I don't know how to do boldface with pen. Okay, so this vector, if it goes over 2, I'm going to write 2 times I hat plus 7 times j hat. So I hat is how far, the number in front of I hat is how far horizontally the vector goes. The number in front of j hat is how far vertically it goes. All right? So it's that simple. If you had a vector, let's say w, that looks like maybe this, let's say this is a vector w, we can see that this vector actually goes to the left. So it is going to have a negative x component. So it's going to be like maybe negative 3, and then this might be negative 10. All right. So the vector w is going to be negative 3 I hat minus 10 j hat. All right. So that's how it works. If we were working with vectors in 3 dimensions, you would have out of the page as well. So you'd have how far over, how far up, and how far towards you guys does the vector go. And in that case, we would have a plus k hat. So that's the third dimension. Okay. And if we want to get into theoretical physics, you know, like in string theory, there's 26 dimensions, so you have 26, you know, terms if you wanted to describe a vector. So it's just, yeah. All right, so one of the things we can do with vectors is we can add them. So if you are adding vectors, what you do is you simply add the I component to the I component, and you add the j component to the j component. It's that simple, okay? So if I add the I component to the I component, I'm adding 2 to negative 3. So that's going to be negative 1. So I could call it negative I, all right? And then I'm adding 7 to negative 10. So that would be minus 3 is the j component, all right? And so that would be the vector v plus w. All right. So this operation that I just showed you is called vector addition. And when we are doing vector addition, both of the things must be vectors. Okay? Let me write something that doesn't make sense. I almost don't even want to write it down because it's so bad. Okay? What if I said v plus 7? That just makes me cringe. Doesn't it make you cringe? The reason is that this is a vector, but the number 7 is not a vector. It's called a scalar. Okay? A scalar is just a number. See how 7 doesn't have i's and j's. It's just a regular number. Okay? So this is like adding apples to oranges. You can't do that. No. You could do v plus w because those are both vectors. You can add 2 vectors together like I just showed you. You could do negative 5 plus 2 because that's adding 2 scalars together, but you cannot add a vector to a scalar. Okay? So this is forbidden. No, do not do that. The other thing you could do is you could take a vector, okay, and you could multiply it by a number, okay? So what if I wanted to calculate the vector 5v? All right? So what I would do, so that would be 5 times the vector 2i hat plus 7j hat. Okay? And so what you do is you just distribute the 5. So I distribute the 5 to the first term. I distribute the 5 to the second term. Okay? So it would be 5 times 2 times I hat plus 5 times 7 times j hat. Okay, so that would be 10I plus 35j. All right. So you can multiply a number by a vector. So you can't add a number to a vector, but you can multiply a number by a vector. Okay. So this operation is called scalar multiplication. Okay. So that is a common vector operation. There's another thing that we can do with a vector, which is called getting its magnitude. Okay, so the magnitude of a vector means to do the Pythagorean theorem on that vector. Okay, and the magnitude, to indicate the magnitude, I will put bars around the vector. So bars like that. So if I did the Pythagorean theorem on the vector v, the vector v goes over 2 and it goes up 7. So I want to do the Pythagorean theorem to get the magnitude. Okay, so to do the Pythagorean theorem, I do square root of how far over it goes, which is 2 squared, plus how far up it goes, which is 7. Okay, so that would be square root of what, 53? And you would type in a decimal, or you get a decimal number for that. Okay. So this is vectors from an algebraic standpoint. When I say algebraic, that means in terms of equations and numbers and stuff like that, okay? But we can also understand vectors in terms of pictures, okay? So if I want to know about vectors in terms of pictures, so let's say I have a vector v, and I have a vector w. Hello. If I have a vector v and a vector w, and I want to add them together, you can do what's called the parallelogram rule, where you take the two vectors, and notice that the two vectors are tail to tail. So you put the two vectors tail to tail, okay, and you make a parallelogram out of those two vectors, and then the sum of the two vectors is the vector that goes across the parallelogram. So that is v plus w. Okay? And then once we've added them together with the parallelogram rule, we can then take that vector and move it someplace else. Okay, so it doesn't have to start there. We can move it if we want to. All right, so that is vector addition in terms of pictures. The other thing I wanted to talk about is scalar multiplication in terms of pictures. So let's suppose that I had a vector, let's say, let's say the vector is called A, and let's say that A looks like this. If I made the vector 3A, the vector 3A, so that is a scalar multiplication, it's going to take this vector A, and it is going to multiply its length by 3. So it's going to be in the same direction, but it's going to be 3 times the length. Okay, so that would be 3A. if you multiply a vector by a negative number, so let's say I have the vector negative 2a, then that scalar multiplication would multiply the length by 2, but because there's this minus sign, it would reverse directions. So it would be like that. All right. So that is, so this is addition in terms of pictures, and this is scalar multiplication in terms of pictures. The magnitude of a vector is simply its length. Okay. So it's the length of that arrow is the magnitude. All right. So what if I have my vector v, and just like there's scalar multiplication, there's also scalar division. Okay. And what if I divide it by the length of v? Okay. So this is valid because the magnitude of the vector is just a number. What was the magnitude of the vector v? It was square root of 53. Okay? That's just a number. So it's okay for me to divide by the magnitude of the vector. Okay? So what happens, like what would happen if I did 1/2 a? Oops. What if I did a over 2? That would be half the length for the vector. Okay? So if I take the vector v and I divide it by its magnitude, so what if I have a vector of length 2 and I divide it by its magnitude, which is 2, what's going to be the new length of the vector? It's going to be 1. So this vector has length 1. Because, if the length is 5 and we divide by the magnitude, which is 5, that's new length is going to be 5 over 5, which is 1. If the length is 27, then we take a vector of length 27, we divide by 27, 27 over 27 is 1. Okay? So this is called a unit vector. Okay? And if something is a unit vector, we put a hat over it. So instead of using the arrow, we put a hat on top of it. So this is the unit vector v, which is equal to v over its magnitude. Okay, so that's shorthand for we divided the vector by its magnitude. Okay. We cool with that? So that's magnitude. I'm almost done here with my lesson. Just a couple more things to cover. So this is CHL 9/3, period 5, part 2. So the next thing I want to talk about is something called the dot product. And the dot product takes two vectors and it turns them into a scalar. Remember, a scalar is just a regular number. Okay. And it's denoted by, so let's say we had our two vectors, v, and we dot it with w. Okay? So how do we compute the dot product? Well, it is the dot product is going to be equal to the x component of v times the x component of w plus the y component of v times the y component of w. So x component times x component plus y component times y component. If you had a three-dimensional vector, you would also have a term of z component times z component. Okay, if you had 26 dimensions like bosonic string theory, you would have 26 terms. It would be okay. So that's how it works. And so let's go ahead and compute the dot product of those two vectors. So I can see that I want to do 2i plus 7j dotted with minus 3i minus 10j. So it's going to be I component times I component, so 2 times negative 3. Notice how the x component does not include the I. It's only the number in front of the I. Okay? Plus the j component times the j component, so 7 times negative 10. Okay? All right. So notice how we've taken two vectors and we've turned it into a number. So see how we have i's and j's on the left-hand side, but once we do the dot product, the i's and j's go away because we're taking vectors and turning them into scalars. So we have minus 6 minus 70. So this would be equal to minus 76. That's the dot product. All right. What does the dot product mean? It turns out, so if you want to see the proof of this, come to my Zoom room during office hours. But it turns out that the dot product, v dot w, is equal to the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. Okay. So yeah. So that's what the dot product ends up being. It's the product of the magnitudes times a cosine factor. And again, I'm not going to prove that unless you come to my office hours. I can show you. It's fairly straightforward. Okay. By the way, what if I had the vector that was what if I had the vector c, and what if the vector c was just equal to I? This vector, because I didn't write anything in front of the I, it's sort of implicitly assumed that the number in front of I is 1. Okay? And because I didn't even bother to write the j, it's implicitly assumed that the number in front of j is 0. Okay? So for example, if I did v dot c, that would be, it would be 2i plus 7j dotted with 1i plus 0j. And so that just makes me think of orange juice. I'm thirsty. So that would be equal to 2 times 1 plus 7 times 0 equals 2. Okay. The other thing I wanted to talk about is the cross product. Cross product. And this will be the last thing I discuss for today. So the cross product takes two vectors and it turns them into another vector. All right? And there's a couple of simple rules for calculating cross product. I bet you, if you've heard about the cross product before, I bet you that the way I'm about to teach you cross product is totally different from anything you have ever seen. All right? I'm excited. Okay. Let's think about IJK. Isn't that the correct order of IJK? It is, right? That's the way they go in the alphabet. KIJ is also in some sense in the correct order, because if we start at I, J, and then because I got to the end, I go back to the beginning and I get K. So this is the correct order of I, J, and K in some sense. It's I, J, K. I, J, K. What if I did, J, K, I? That is also in the correct order. Why is that? Because I start at I and I go to the next one, but because there's nothing after the I go back to the beginning and it's J. J comes after I, and then K. So these are all in the correct order. Okay? But what if I have KJI? That's reverse order. See how that's backwards? Okay? Similarly, if I have K, what if I had JIK? That's reverse order. Okay? Because it's IJK going backwards from right to left. Okay? Similarly, if I had IKJ, that's also backwards. Okay? So this is reverse order. Okay? So, what if I want to know, what is I cross J? I cross J is equal to K. How do I know that? Because it is in the correct order. All right? I cross J is equal to K. See how it's IJK? So anytime it's in the correct order, it's a plus. Okay? What if it's in the reverse order? Like, for example, JI. See how JI is the reverse order, so that's going to be equal to minus K. So so basically you need, to do a cross product, you need all three of the letters, and it's going to be a plus or a minus depending on whether it's in the correct order or it's in the reverse order. Okay? You need all three of them in order to do the cross product. What if I did I cross I? Well, that's not in the correct order or the reverse order, so that's going to be equal to 0. Okay? So I'm going to show you how to compute a cross product. What if I had two vectors? What if I had a vector 4i plus 2j? All right? And I want to cross that with, let's say, 7j plus 3k. Something like that. So in order to compute that cross product, what you want to do is you want to go ahead and FOIL it. It's important, in the thing about cross products is they're different from regular multiplication. In regular multiplication, 4 times 5 is equal to 5 times 4. But if you do cross products, I times j is different from j times I, because one is the correct order and one is the reverse order. Okay? So I'm going to FOIL this, but I'm going to make sure that the first terms are always ahead of the second terms. Okay? So my first is going to be these two times each other. So I have 4 times 7 times I cross j. And then I have the outside term, which would be that one. So that's going to be 4 times 3 times I cross k. And then there's the inside term, which is this, which is going to be 2 times 7 times j cross j. And then I have last, which is this one, and that's going to be 2 times 3 times j cross k. All right, so it's got 4 terms. First, outside, inside, last, FOIL. Okay, now let's figure out what these cross products are. I cross j is ij, that's the correct order. It's not reverse because it goes ijk. So that's the correct order. So this is going to be k. So I'll replace that with k, and I'll 4 times 7 is 28. I cross k. Is I cross k in the reverse order or the correct order? I'm going to wait a couple seconds to see if someone can type it in. Reverse order or correct order? Okay, it's reverse. That's right. The reason it's reverse is because what comes after I in the alphabet? J comes after I, right? So this is reverse. So anytime it's reverse, we're going to have a minus sign. And then what's missing out of the 3? Well, J is missing. So that's going to be minus J. So this is going to be minus 12J. All right? J cross J, that's 0. Because J cross J is 0. Because anytime, you have to have all 3 in order to do a cross product. And then lastly, J cross K. Oh, wait a second. Is that in the correct order or the reverse order? What comes after J in the alphabet? Good, it's in the correct order. So that means that I'm going to have a plus sign. So that'll be 6 times the other one, which is I with a plus sign. Okay? So this would be the cross product of those 2 vectors. So that's kind of a weird way of doing cross product. It's probably different, but I just wanted to give you a new way to do cross product. Now, what does the cross product mean? Well, the magnitude of the cross product is equal to the magnitude of the first vector times the magnitude of the second vector times, now remember the dot product was, the dot product gave us the cosine of the angle between them. The cross product gives us the sine of the angle between them. Okay? So, and that's the magnitude of the cross product. You have to remember the dot product is going to give you a number, a regular number, a scalar. And then the cross product is going to give you a vector, but the magnitude of that vector is very similar to the cross product, but just with a sign instead of a cosine. All right, so that's my lesson for today. And we're going to go ahead and switch over to the Zoom room. So I will catch you in the Zoom room.